Hi, we're going to be doing Lab 9 here. Let's go on it. Okay, so here's Lab 9. What is the domain? The domain is the x values, which are 1, 2, 3. And I use my set brackets. What's the range? Those are the outputs. Put it in numerical order if you can, which is 4, 5. You don't write 5 twice. And they want to know, is the relation a function? And some people like to do a function mapping to see if it is. You can do that. This pencil is so dull, I don't know if I'll be able to fit my function mapping in here. 1, 2, 3. That's the domain. Range is 4, 5. 1 maps to 5. So far so good. 2 maps to 5. That's okay. That 2 maps to 5. That both of them are going to 5. That's okay. And 3 maps to 4. That's okay. Each one of these goes to one thing, so that makes it a function, so we say yes. So what's the domain here? 1, 1, 3, so just 1, 3. What's the range? 2, 4, 5. If you can write it in numerical order, you do. Is it a function? Let's see, 1, 3, and 2, 4, 5. And then we see our mapping. 1 goes to 5. That's okay. 1 goes to 2. That's not okay. So it's not a function. Then tell us whether or not the graph represents a function. If you can draw a vertical line, it's called the vertical line test, and hit the graph only one time, it is a function. So every place that I draw a vertical line, it only hits the graph once, so yes, it is a function. Whereas this one, if I draw this vertical line here, it hits it twice. So it doesn't have to it only has to be one spot that it hits it twice. So this is not a function. And state whether each of the following graphs are functions. So yes, a function, no, not a function. And so it hits it once here with a vertical line, but here it hits twice. So it's not a function. Now it doesn't matter if it has other bad spots. Here's another bad spot, or if it does. Either way is okay. So here they're asking us to graph this. X, Y. I'm going to be picking Y's. So I'm going to pick Y as 0. When I put that in, just imagine it looks like X equals 0 squared minus 4. Imagine you put in 0 there, then you're going to get negative 4. Imagine you put in 1 there. So if you put in 1 here, you're going to get negative 3. Imagine you put in negative 1. Negative 1 squared is exactly the same as 1 squared was, so you're going to get negative 3. Imagine you put in negative 2. We'll put 2 and negative 2. You get the same thing from either of those or 0. Then you plot these points over 0 up 2, over 0 down 2, over negative 3, 2, 3, up 1, and down 1, and over negative 4, 0. And so I have something that sort of looks like this, and I can kind of see the parabola going there. We've talked about that when you have y to the second, x equals some y to the second, that it's going to be on its side. And so this is a parabola laying on its side. And so something along these lines. I did a little better on my rounding on the top. This is rounded. On the bottom I didn't do so good. So no, this is not a function because a vertical line hits it twice. The domain, if I go back here, I can't go any further this way, right? So the domain is, because there's infinitely many values, ordered pairs here, but what those ordered pairs all have in common is that their x value are all greater than negative 4. So the domain here is x is greater than or equal to negative 4. Now the range though, these values go up and up and up, and I tell people, you know, imagine putting a box. Could you contain it in a box? And the answer is I couldn't. It would go up out of the top of my box, and so that makes your range, and down out of the bottom of your box, that makes your range all real numbers. Okay, that's lab 9.